Hi, this is Dr. Pranjali Sharma, and in this video lecture I am going to teach you Taylor's theorem up to remainder Rn, and it is a part of differential calculus. So what is Taylor's theorem up to remainder Rn? If a function fx and its first n-1 derivatives are continuous in closed interval a to a plus h, and the second condition is first nth derivative of fx exists in open interval a to a plus h, then there exists a value theta which is between 0 to 1 such that the function fx plus h can be expanded as fx plus h f dash x plus h square by factorial to f double dash x up to the last term which gives us remainder Rn, and the last term will be hn by factorial n fn x plus theta h, and this last term is known as remainder Rn. And next, to get Maclaurin's theorem, with remainder Rn, it is a particular case of Taylor's theorem. So if we take it as equation 1, we put x is equal to 0 and h is equal to x in Taylor's theorem. So the function becomes fx, and it can be expanded like f0 plus x f dash 0 plus x square by factorial to f double dash 0 up to the last term x to the power n by factorial n fn of theta x, and this last term will be the remainder Rn. So next we will solve an example using Maclaurin's or Taylor's theorem. So we are taking an example. So the question is expand log 1 plus x up to remainder R3, let it be. So using Maclaurin's theorem with remainder, so here we have to use R3 formula is fx is equal to f0 plus x f dash 0 plus x square by factorial to f double dash 0, and we have to expand it up to R3. That means Rn is equal to R3. Hence the last term will be x cube by factorial 3 f triple dash, and since it's remainder, that means it is theta x. So take it as equation number 1, and we get the series. Since fx is log 1 plus x, therefore f0 will be log 1, which is 0. Now f dash x will be 1 upon 1 plus x, which can be written like 1 plus x inverse. So f dash of 0 will be 1. Alright, next f double dash of x, it will be minus 1 plus x to the power minus 2, or it can be written like minus 1 upon 1 plus x square. So f double dash 0 will be minus 1. Next, f triple dash of x will be 2 into 1 plus x to the power minus 3, which can be written as 2 upon 1 plus x whole cube. And since we have to find out f triple dash of theta x, so in place of x we have to put theta x. So f triple dash theta x will be two upon 1 plus theta x whole cube. So we have all the values which is needed. Put all the values in equation 1. Put values in equation 1. So fx is log 1 plus x, f0 is 0 plus x into 1 plus x square by factorial 2 into minus 1 plus x cube by factorial 3 into 2 upon 1 plus theta x whole cube, and this term is known as remainder R3. Hence we have expanded the function up to R3. So in this video lecture I have taught you what is Taylor's theorem with remainder, what is Maclaurin's theorem with remainder, and next